Hi guys, we are going to talk about a lot of factoring. Before we get into polynomials and stuff in Algebra 2, what I want to do is take a second and just review factoring that you have seen before. It just might not be that familiar. Okay, so when there is a coefficient or a number, when you have a leading coefficient that's 1, okay, and this title is incorrect. Okay, so when there is a coefficient of 1 in front of x squared, you're going to use this method of factoring. We have our quadratic right here. I notice there's a 1 in front of x squared, so I'm like, fantastic. We're going to use this method. We're going to write a set of parentheses right away. And I'm going to ask myself, what two numbers will multiply to give me 20 and add to give me -9. Okay, so I'm going to go through my factors. I'm kind of really drawn to 4 and 5 right now because I know 4 times 5 is 20 and 4 plus 5 is -9. However, 4 plus 5 is +9. However, I don't want +9. I want -9. In order for that to work, in order for them to multiply to be a +20 and add to be -9, they're going to both have to be negative. -4 times -5 gives me 20. -4 plus -5 gives me -9. Okay, so now that I have those two, now that I have my factors, they're going to go into the second spot in my parentheses. The first spot, I'm just going to take my x and split it up. That's it. You guys take a second. Try this one. Remember, you are thinking of what will multiply to be -12 and add to be 3. You're going to do it the exact same way I just did right there. Okay, so congratulations if you got this. We realize, or going through it, that the only way to multiply things to get -12 and add to get 3 is if you use 6 and -2. I already split up my x's to go into the first section there. Okay, so I have a +6 and a -2. So if you guys keep that pattern going, what will multiply to be your last number and add to be your middle number? Do not forget about your negatives. The negatives count. Whatever sign is right in front of that term goes with that particular term. Okay, so now on to my favorite part of factoring, noticing those special patterns. Let's look at part A there. For part A, I'm going to notice something crazy is going on. I don't have a middle term, I'm missing an x term, and 49 is suspicious. I think about it, I'm like, isn't 49 the same as 7 squared? And it is. Because that happens, because you're missing a middle term, because you have a subtraction sign, and because both terms that are there, something's being squared, that is your difference of squares pattern. When that happens, all that you have to do to factor is write your parentheses right away. Then you're going to take whatever is being squared in the first spot, that's just x, x is what is being squared, and you're going to split it up between those parentheses, and you take whatever is being squared in the second spot. For us, that's 7. 7 is what's being squared. And in order to get your middle term to cancel like that, your signs have to be plus, minus. Let's look at the second one. The second one, I have a middle term. However, I'm going to check for this next pattern. I want to see if it's a perfect square. If it's a perfect square, that means it fits this criteria. That means there's something being squared here, and there is. In this case, it's d. Something is being squared in your last spot, and it is 6. 6 is being squared to give you 36. And your middle term is equal to 2 times whatever you're squaring in the first spot, that's a d, times whatever you're squaring in the last spot. So we're going to see, is my middle term here equal to 2 times d times 6? And it is. It's 12d. So because of that, this is a perfect square. And when I factor that, it goes right into that format. I don't even need to put the 2 parentheses. I could just to make sense of it, but you'll see in just a second why I can just rewrite it as squared. Okay, so when I factor a perfect square, again, I take whatever I'm squaring in the first spot, and I split it up, and then I take whatever I'm squaring in that second spot, and I split that up. Only what's different is your sign. We're not going to have a plus minus. You only do a plus minus when you want these to cancel. We're going to have 2 addition signs. And you'll notice how they're exactly the same. Because that happens, I can rewrite this into d plus 6 squared. You guys take a second and try C. I'm going to tell you right now, more than likely it is a perfect square, or it's a special pattern because it's on the slide. So check it out. Okay, so for that last one, again, we're going to check for that perfect square pattern. We're going to say, is something being squared in the first spot? Yep, it is, z. Is something being squared in the last spot? 13 is squared to give you 169. Then we're going to say, is my middle term equal to 2 times whatever is being squared in A times whatever is being squared in C? And it is. It's equal to 26z. Now, I do have a negative sign. Whenever, and we'll talk about that later. Let's just get our numbers in there. Okay, so we're going to stick in whatever is being squared in that first spot. That's going to go first. The last spot is reserved for whatever is being squared last. Now, the sign here is a little bit different. You'll notice I have a minus plus. That's fine. That's still a perfect square. That just means that I'm going to have 2 subtraction signs. Think about it. Whenever you FOIL this guy out, if you multiply those 2 negative terms together, that's where that positive comes in. It would not work if you had a plus minus. That one you can't factor. You can't do. Okay? So in order for it to be a perfect square, you either need to have plus plus or minus plus. And then for a difference of squares, it's got to be a minus. Does not work if it's a plus. You get imaginary numbers, and we're not ready for that yet. Okay, so we're going to say this is a perfect square. And then again, z minus 13s are the same, so I can rewrite it into z minus 13 squared.